Silicon chips are part of modern life as we know it. They're used in virtually every electronic device that plays such a vital role in all that we do. It's hard to imagine a world without them. Steady improvement in their performance has increased the power and speed of so much of our technology. But the pace of this change cannot be sustained. As Professor Alwyn Seeds, head of the Photonics Group at UCL, explains.
I've got here a typical part of a computer. Silicon chips communicating through copper. This component gets faster and faster, but our ability to communicate into the computer and out of the computer is limited by the copper connections that we currently use. In contrast to that, if we take some optical fibre, you can send the entire contents of your laptop's hard drive through that single fibre in less than a second. What we're trying to do is to bring that speed of communication actually onto the silicon chip.
While silicon is an excellent material for processing, it does not emit light. Previous attempts to grow light emitters on silicon have struggled to overcome the differences in the structure of those materials and the silicon itself. Dr. Hee-Young Liu is leading research in this field, and together with staff and students at UCL's Electronic and Electrical Engineering Department, they've made a key breakthrough in this area.
We are developing new technology to put light in silicon platform.
People have been trying for more than 30 years to find ways of growing compound semiconductor materials on silicon. And we set up the molecular beam epitaxy facility at UCL specifically to address this long-standing problem. If you simply try to grow the compound semiconductor on the silicon, the lattices of those crystals, that's the spacing between the atoms, don't fit together. So you get what's called an amorphous material, which you can't make a light emitter out of.
But we recognize the nanocrystal could be a better solution.
When you take a material down to this very, very small size, you can adjust its properties to be subtly different from the properties of a material at a larger scale.
Using this approach, Dr. Hee-Young Liu and his research team have created a laser that can grow on one single silicon chip.
What we have done is provided a method to generate the light actually on the chip itself, and that is the holy grail of silicon photonics.
This innovation will have far-reaching benefits to manufacturers as well.
At the moment, we have to pretty well hand-assemble optoelectronic components with silicon integrated circuits. It's extremely demanding of labour and it's extremely costly. From our technology, the whole thing can be done as an automated manufacturing process. That is a huge cost saver, and since we expect to get better technology but to pay the same price for it year by year, that is essential to actually realise this vision.
Unbridled from the limitations of copper conductivity and able to transmit signals at the speed of light, the faster, more powerful chips of the near future will be world-changing for all of us.
Once we put the laser in silicon, we can make the computer much faster and also at the same time make internet much faster.
This will be a ubiquitous technology. You will find it in computers, you will find it in communications. I think every one of us who uses those everyday devices will make use of this technology.